going to be going through another MCP project from the data engineering series. Um, yeah, no, super stoked to be going through this. This is going to be using Grafana. It's the final project in the series, and yeah, no, super excited to go through it. I think it's a really good way to end what we've been doing so far with the series, getting MCPs to do the heavy lifting for us in a data engineering space. So yeah, we can jump into it. So build description. Build real-time monitoring dashboards that visualize PostgreSQL data using Cursor with MCP, Model Context Protocol. So the difficulty set here is mildly spicy, so it is certainly challenging. Totally doable though, even if you're a beginner, but it is like potentially a harder project than the previous ones. That's just something to keep in mind. The time set for this is 90 minutes, and we've got the list of related projects here. So there's the PostgreSQL MCP project, the first project in the series where we just set up PostgreSQL and Docker MCPs, use them. Definitely recommend that. There's dbt, data build tool, MCP project, the Jupyter Notebook, MCP project. Yeah, no, it's super cool. So yeah, and we're actually going to be using some dbt stuff, the dbt model that we created in part 2. And if you haven't done that, we'll catch you up to speed anyway. Yeah, no, I think we're good. Cool. And key concepts are Grafana, PostgreSQL, and data visualization. So I'll just read the 30-second summary here. Imagine you've built data pipelines and queries that generate customer insights. Your database has revenue trends, order patterns, purchase behavior, but your stakeholders keep asking, can you send me a CSV, comma separated value file, or can you make me a chart showing ... You could export data, create one-off charts, repeat this weekly, or you could work like production data teams do. So production data teams use Grafana, which is an interactive dashboard that connects directly to databases. You can write a query once, visualize it as charts, monitor trends, look at setting up real-time alerts, share dashboards across teams or anywhere, and it all updates live, accessible for everyone. So what you'll build in this project, you'll use Grafana to build monitoring dashboards connected to your PostgreSQL and visualize e-commerce data in real time. So why Grafana? Grafana is the industry standard for operational monitoring and analytics. Companies like Bloomberg, NVIDIA, and Salesforce use it to visualize billions of data points. It connects directly to your database and transforms SQL, structured query language, queries into interactive charts. Not sure if this project is right for you. You can check if this is by using the Ask chat here. Super useful. If you're new to Grafana, this project does not require any previous experience, which is so it's a good starting point. So we teach you how to connect it to databases and create professional dashboards. Cool. So first, you'll set up Grafana and connect it to your PostgreSQL database. Then you'll use Cursor with MCP, which is the Model Context Protocol, to build and manage your dashboards through conversation. And that conversation will be happening in the Cursor chat inside of the IDE. So by the end of the project, you'll have a working Grafana dashboard connected to your database. interactive visualizations showing e-commerce revenue and customer metrics. And at the end, we'll be walking through a secret mission that's like a full monitoring dashboard comparing raw versus transformed DBT data, and that's really the tie-in at the end, trying to look back at the previous two projects and understand actually why we did those in the context of data engineering and where that can be helpful for like live monitoring of data with dashboards. So our local setup here on the left-hand side, this is sort of what we're building, is going to be, we're going to be using cursor chat to give natural language commands that'll be picked up by the Grafana MCP to control and configure a Grafana server we'll be hosting with Docker. So it's going to query data, the PostgreSQL database is going to return results, and depending, and that can be displayed to a interactive dashboard via the Grafana server, which we're hosting locally on Docker. Cool, so what are we doing in this project? In this project, I'm going to set up the Grafana MCP to MCP, and you can say Grafana MCP and local Docker image. Grafana is a open source platform that allows you to create live dashboards. Super common in industry. I will use the little thing up here. You can see that Grafana is an open source platform for monitoring stuff. It allows you to visualize data from various sources through dashboards, charts, and alerts, helping you understand the performance and health of your systems. Yeah, super cool. Grafana is an open source platform that allows you to check out the project in the link chat. Tasha's just put it in there. Definitely feel free to follow along with what I'm doing. I think it's a real cool project. Just seeing I spelled allows wrong. That allows you to pull data from multiple remote or local data sources and create visualizations. I'll use it to visualize e-commerce data. So what are we doing in this project? In this project, I'm going to set up Grafana, and that for me is the MCP and a local Docker image hosting Grafana. Grafana is an open source platform that allows you to pull data from multiple remote or local data sources and create visualizations, we can say, with this data. I'll use it to visualize e-commerce data. That's what we've got in the data set. Cool, so we'll be walking through the step-by-step guide in this, but low touch, no touch, really good options if you're looking for, if you're more confident with this, you're looking for a challenge, definitely give those a go. Cool, so this is the video you're watching now. Step 1, configure Grafana MCP inside of Cursor. So it's time to connect Cursor to Grafana. We'll set up the Grafana MCP server so you can create dashboards, configure data sources, and visualize your data through natural language. We can use the ask prompt here to ask the Network AI, what is the Grafana MCP, how does it work, and it's going to give us a real good answer if we're not familiar with it. So I really encourage you to use this as well as the definitions feature here whenever you see it and you feel like you're stuck or you need it. So in this step, you're going to create and configure a Grafana Docker container. and connect cursor with the Grafana MCP. So in this step, I'm setting up a Grafana Docker container to host my Grafana instance. Without an MCP server, I cannot connect and use the specified MCP. Thank you, Sean. Thank you, S Fits, Mr. Paramedic. What are we doing in this step and why is it important? In this step, I'm setting up Grafana, setting up a Grafana Docker container to host my Grafana instance. Without an MCP server, I cannot connect and use the specified MCP. Cool. Okay, so first part of the step is checking your current MCP setup. Before we add Grafana, let's actually see what MCP servers you already have configured. So I have cursor open here. I'll just pull it onto my screen. And so from now on, I'll be running this in like a sort of split screen setup. So you can see both what I'm doing in cursor and where I'm looking at in the project. That reminds me, Sean, your comment, Rocket Man. A lot of the work I did in previous internships have been using Grafana. It's a real popular tool in aerospace, which is where I used to work. So yeah, definitely Rocket Man, and definitely have used Grafana a lot. I didn't use the MCP though, and I wish I had. I didn't exist at the time, but still, would have been great. So we'll open up cursor. We'll click on the settings icon in the top right. We'll select the MCP from the drop-down menu here. We've got no MCPs at the moment, so I don't see Docker and Postgres MCPs. You definitely would if you've done the first project or more, and that's totally fine. But I don't see it, so I'm going to go down this route and continue to set it up. So no worries, here's the fast track setup. It takes about 15 minutes, that's pretty generous. Definitely doing 5 or 10. Will get you set up with Docker, Postgres, and then Grafana at the end. So you'll set up Docker desktop, if it's not already set up, a PostgreSQL container, UV package manager, MCP servers, in this case Docker and Postgres for this like catch up, and load the demo data into your PostgreSQL Docker image or database. So we're going to install Docker Desktop. First, check if you already have it installed. So open a terminal on Mac or PowerShell on Windows. Just do that now. So if we copy this command from here and run it inside of my PowerShell, we can see that I have a Docker build number and build ID, so we're good to go. And then installing the UV package manager, we'll check if we have the file on our desktop first. So I'll just minimize this, close the settings, open project. So I don't have anything on my desktop. So I don't have a folder. Let's create it. Select open project and create a new folder on your desktop called MCP data series. So new MCP data series. Now we're going to open the terminal in cursor. That's just an update. So I'll go into this. terminal, new terminal. So we're going to check if we have UV installed. What do you see? I see a version number, which is correct. Cool. And if you don't, totally go and install and set it up there. So next, it's going to create a PostgreSQL container and load the data in. So we will run the UV init. This is totally fine. Project is already initialized. I've already set up projects on my desktop before, so that's why that's coming through. Hello, Raj. Raj, yeah. How are you, my friend? And yes, Grafana mission control, powerful tool you can use. Yeah, for sure. We used a program called YAMS for mission control stuff. Yet another mission control service. That's a good idea. I should set up Grafana so I can monitor the live stream view account. It's a really good idea. Cool. So as I was saying, project is already initialized, completely fine. Just means I've set something up on this before. So what I'll do now is I'll run this Docker creation command. Container created successfully. That's good. It does take a little bit of time for PostgreSQL to start up in a Docker container, so we'll just give it a couple seconds. I might just use this time to take off my jumper. It's quite warm in this room. Okay, that should be enough time. So what we'll do now is we'll download the demo data and then load it into the database. We should see a bunch of a schema and then 4 tables being created and then insertions into those, which we do, which is really good. It's over 40,000 rows of e-commerce data being inserted, happening pretty quickly. So there's a possibility you might run into duplicate keys or existing tables if you already set this up, and that's definitely a possibility. So you can just move on, given it's already there. Cool. So now we're going to configure Docker and Postgres MCP servers inside of Cursor, because we already understand that they're not there. So let's set up Docker and Postgres MCPs. We'll add the Grafana in the next section. So we'll go back to settings. Should close this for now. Select MCP from the sidebar, and then select Add Custom MCP. So we're on Windows. Thank you for the good encouragement, Sean. So we'll paste this in here. So what does this configuration include? It includes both the Docker MCP, which lets Cursor control Docker containers, and Postgres MCP that lets Cursor query the PostgreSQL database set up inside of Docker. Sweet, so we're all set. We now have the same setup from someone who's completed the PostgreSQL MCP project. And now we're going to move on to adding the Grafana configuration. So we're going to create Grafana Docker container first. Now let's create the Grafana instance using Docker. Think of Grafana as your visualization engine. It connects 2 databases, runs queries, and transforms the results into interactive charts and dashboards. So what is the difference between Grafana and SQL? SQL, structured query language, lets you query data and see results as text tables, rows and columns of numbers. Grafana takes those same SQL queries and turns the results into visual charts, bar charts, line charts, stat panels with big numbers. SQL is great for analysis, but Grafana is built for monitoring. Dashboards that update automatically, metrics that stand out visually, and alerts when something goes wrong. Alright, configure either. You write SQL queries in both Grafana, or in both. Grafana just makes them visual and interactive. So that's definitely the point to highlight from this. Grafana it's not a new language, it's not anything really past a way of visualizing data that's been really well polished and is like an industry standard. A little bit like dbt isn't a new language. You can use a lot of different languages inside of it, similar to Grafana, to show off data you already have. Hello, Roy. Sure, let's do it. Awesome. Glad you're following along, Raj. Super cool. We'll run it in Docker, so you don't need to install anything permanently on your computer. When you're done with the project, you can delete the container and it's gone. No leftover software. So we'll do this now. Open a new terminal in Cursor. In Cursor, go to Terminal, New Terminal from the menu bar. We can use the rather convoluted hotkey shortcut there, and we'll run this in the terminal. Cool, so you can see here that worked pretty quickly. The chances are you wouldn't have pulled the latest Grafana instance using Docker, and so you'll need to install it, and it'll just have some information that just says like pull, a few things being pulled separately, and then just like this image here, and that can take 30 or 40 seconds depending on internet speed, but completely normal. So that's all good. It also generally will give you a notice saying you can't find this locally, so it's going to go install it. Is Grafana like Power BI? Like, you don't know what Power BI is. It could be. Grafana is a open source visualization platform tool that lets you take in data sources and visualize. Your data source can be local or remote or anything. But I'm unfamiliar with Power BI. Cool, so we can, just to show off what we're doing here, obviously we created the PostgreSQL database inside of Docker, and they've also created the Grafana instance here. You can see they're both running inside of Docker, so that's good. Don't need to check that, but it's just a good verification that what we've done is correct. So we can open this, we can get taken to Grafana. It's a little bigger, which is the login page. So Grafana's default credentials have like the password and username as admin. But we'll be running with this. You'll see you get the chance to change this after you go through the first, or after you input it initially. It'll ask you if you want to change it. We'll be running just with this. It's not a huge deal for something that's just being around locally, but you can see here that it's saying that default password, but you can just skip. That's what we're going to do for this, but no problem to change it as well. Cool. So Microsoft Power BI. Yeah, I am unfamiliar. I have to do some research, Roy. See what it's like. Sounds like a cool tool. Cool. So now Grafana is running. locally. We're logged in. Now we're going to go create a service account token. This is like an effective API token to access the Grafana server that's being hosted, that the cursor will use through the MCP to access it. So I'll read this out. The MCP needs an API token to interact with Grafana's API, creating dashboards, adding panels, and managing data sources through code instead of manually clicking in the UI. Cool. So we'll go into this, go into service accounts. We'll click add service account. We'll enter the name MCP account. This doesn't really matter an awful lot, but we're just going to call it that. We're going to click, we'll select admin, which is quite important. You get the opportunity if you've already gone past this, you can go and change it, but I recommend doing it here. Click create. Then we're going to click add service account token. Again, this isn't super important what this is called, but we'll just call it MCP access. So you don't, there's another option here around expiration. You don't need to set an expiration date. You totally can if you want to, but for this we're not going to set an expiration date. And then we're going to click generate token. So now we can click copy to clipboard. We'll be using this shortly, and if you need to come back to it, it is good to know that you only get the opportunity to copy it once. So if you don't have a clipboard, you can look at your clipboard history. It might be a really good idea to just keep this tab open and don't close it and don't exit out of this window. I do have a clipboard history, so I'll just click copy to clipboard or copy to clipboard and close. And we'll use this in a moment. Yeah, so paste this token in a safe space. So what is a serviceable account token? A serviceable account token is like a password that lets Grafana's MCP server authenticate and control Grafana. Unlike user passwords, tokens can be revoked individually and have specific permissions, just like an API key. What is the admin role? The admin role gives the MCP full access to create dashboards, configure data sources, and manage visualizations. Cool, so now we're going to jump back to cursor and actually use this API key or service account token as they call it. Great, you've got your authentication token. This is the key that lets cursor control Grafana, create dashboards, configure data sources, and manage visualizations all through chat. Now let's add Grafana to your MCP configuration. In cursor, click the settings icon. So I'll just close this or minimize it. I'll close this so I have some more space to point. So I'll click the settings icon. I will select the MCP from the left sidebar. And we can see we've got these two servers set up, which is good. And we're going to go and add this. So your MCP.json should already have Docker and Postgres configured. Add this below your existing MCP configs. So replace your token with the token you copied earlier. So I'll just paste that in there. And then I'll just copy this entire code block. What does this Grafana configuration do? So command docker, the MCP runs Grafana's tools inside a Docker container. Grafana URL, where you'll find the Grafana instance hosted locally. So in this case, host docker internal 3000 is how we've got it set up. Grafana service account token, the authentication token we just created, it is this. And transport st.dio, how cursor and the MCP communicate through standard input output. Yep. Cool. So this setup lets Cursor control Grafana by sending commands through the MCP server with that token set up. So we'll go and add this. I'm just pasting in the copied code block I had before with my token in it. You can see that there. And there's a hint here. If you see any issues, like if I didn't have a comma there, for instance, this would break JSON formatting. So definitely include a comma. Nice, you've just configured the complete MCP setup. So that's for Docker creating containers, Postgres for storing data, and Grafana for visualizing it all. This is all controlled through Cursor's chat, which is good. So, how did you configure the Grafana MCP server in your mcp.json file? I connected Cursor to Grafana by adding the Grafana MCP block to my mcp.json file. The Grafana MCP configuration includes, a command includes a command to run using Docker, args, arguments that get passed in, that can be passed in on runtime, and environment variable, so in this case Grafana URL and service token. So how did you configure the Grafana MCP server in your mcp.json file? I connected Cursor to Grafana by adding the Grafana MCP block to, code block to my mcp.json file. The Grafana MCP configuration includes a command to run using Docker, args, arguments that can be passed in on runtime, and environment variables. So that's, in this case, it's a Grafana URL and a service token. Cool. So we're going to save and restart Cursor now, or save the file, then restart Cursor. Now that you've added Grafana to your mcp.json, let's restart Cursor so it picks up the new configuration. Save the file, and then quit Cursor. Don't just minimize it, and then reopen it. This is stuff. Cool. So now we're going to reopen Cursor. Click the settings icon and select MCP. Now we're going to verify all MCPs are connected. It can take some time to load some tools in. You guys just finished all of them now, which is good. But it can take a bit longer as well. So if we see all servers green, we can go down this tab. We see Grafana, the new one we just added, showing a red indicator. It'll look like that. Then we can go down this tab, some explanations there, how to fix that. And then if all the servers are red, all the MCP servers are red, then you can go down this tab. But because we're working in the environment where this is all working, we'll head down this one. So perfect, you've just connected three powerful tools together. Docker, that manages your containers, Grafana, and PostgreSQL. PostgreSQL, which is storing your data, and then Grafana, which is visualizing our data, or is going to shortly. So Cursor can now orchestrate all three through natural language. This is the foundation for building professional data dashboards. And there's a little call out here. What about the dbt MCP? So if you see a dbt server 2 from part 2 of the series, that's fine, keep it there. We'll use it in the secret mission to compare raw versus transformed data. It won't interfere with this project, so totally fine. And in fact, I'd recommend doing the other projects in the series before you do this one. You don't need to, but it gives a really good base. So upload a screenshot of your 3 MCP servers connected. So I'll just use the snipping tool to take a screenshot of this. How did you verify the MCP servers were connected? I verified the MCPs are connected by opening the MCP settings page inside of Cursor. The green indicators mean that a specified MCP server is connected, and the related tools are functional. So how did you verify the MCP servers are connected? I verified the MCPs are connected by opening the MCP settings page inside of Cursor. The green indicators mean that a specified MCP server is connected and the related tools are functional. Cool. So now we're moving on to step 2 now. Hopefully pick up a bit of pace here. That's definitely a big step doing the setup, so good job if you're following along. Great work. Cursor is now connected to Grafana. Here's the thing. Grafana is just a visualization tool. It can create beautiful charts and dashboards, but it needs to know where to get the data from. That is right. Currently, Grafana is running, but has no data to display. You need to connect Grafana to your PostgreSQL database. That connection is called a data source. Let's connect Grafana to your PostgreSQL database. In this step, you're going to create a PostgreSQL data source in Grafana and test the connection to ensure it works. What are we doing in this step? In this step, I'm creating a data source which is ... it's pretty similar to what it sounds like. A data source is a remote or local location that data can be fed in or out of. This connection, this connects Grafana to a real, in this case, local database. Without this, Grafana couldn't display the data from our, say, e-commerce store. I'm assuming it's a store e-commerce data set. Cool. What are we doing in this step? In this step, I'm creating a data source which is a remote, local is not spelled right, remote or local location that data can be fed in or out of. This connects Grafana to a real, in this case, local database. Without this, Grafana couldn't display the data from our e-commerce data set. Cool. Navigate to data sources. First, let's get the data sources configuration page. Let's go to, so we're going to open the data sources page. in your browser. I'll pull this over here so we can follow along. Click Add Data Source. PostgreSQL. What is a data source? A data source tells Grafana where to fetch data from. Grafana supports many data sources, so you would have seen them there, but there's PostgreSQL, MySQL, Prometheus, InfluxDB. Yeah, I'm trying to think of other ones that are, like, you could set up like Excel as a data source, for instance, or Google Sheets, or like, trying to think of some obscure ones. But there's just about anything you can think of. It is supported on here. Any real form of data, and there's ways of linking like cloud providers and whatever, which is really good. Each data source needs connection information, so host, port, credentials. So Grafana can query the database and pull data from your dashboard. So that's what we're setting up now. Configure the data source. Now comes the connection setup. You're about to tell Grafana exactly how to reach your PostgreSQL database, the host address, which database to use, and the credentials to authenticate. Think of this as programming a speed dial. Once configured, Grafana will know exactly where it needs to send data, or take data from in this case. So the name has already been configured. Sometimes it isn't. So if it hasn't, then you chuck that in. But the host we need to fill in there. Database name, we're going to use demo. And for the username and password, we're going to be using app. Oops, that's good. And then TLS/SSL. I'll make a verbal note here. Disabling it isn't necessarily saying it's a bad thing at all. It's actually a really good thing, and but it's just not necessary for demonstrating how to use Grafana locally. That's why we've decided to go with disabling it. Cool. So why host Docker internal? Grafana is running, it's the host we used. Grafana is running inside a Docker container, and the PostgreSQL is running in another container. Host.docker.internal is a special DNS name that Docker provides. It lets containers connect to local services running on your host machine or in other containers. Extra for experts, why not localhost? Containers can't use localhost to talk to each other. From Grafana's perspective, localhost means inside my own container. That's how Docker really works. It's containerized environments, not on the host machine, which is the laptop I'm running this on now. If you use localhost 5432, Grafana will try to connect to PostgreSQL inside its own container, which doesn't exist, and will fail with connection refused. Cool. So we're now going to test and save. Scroll down to the bottom of the page, click Save and Test. Cool, so we get database connection okay. That means it's connected fine. If you get a connection failed, definitely go on this tab. You can use this to troubleshoot. Go to the community, use the Ask addition here. See if it can help you out. It's actually very, very good. Cool. Perfect, the connection is live. Grafana can now reach into your database, pull metrics with SQL queries, and transform them into visual dashboards. Now let's move on to actually creating the dashboards. So quickly, we're going to upload a screenshot of the successful database connection test. That's the test we just did then. how did you configure the database source? I configured the data source. Sorry, not database source. Data source. I configured the data source with host. So we're not going to put the typical just localhost here. We use host docker internal. Database demo, username, app. I can put a stop there. The connection test showed me that the credentials, or that database connection is okay. This confirms that my containerized Grafana instance can talk to my containerized PostgreSQL database. We can say both inside Docker. Cool, so how do you configure the data source? I configured the data source with the host called host.docker.internal 5432. The database named demo, the username app, and the connection test showed me that the database connection is okay. This confirms that my containerized Grafana instance can talk to my containerized PostgreSQL database, both inside Docker. And a note here, this stuff comes from like the app password and username is both set up in that command initially we ran to create the instance. Cool. Cool. So step 3, build your first dashboard. You've connected Grafana to PostgreSQL. Now you need to tell Grafana what to visualize. Your database has revenue, orders, customers, but which metrics actually matter? How should they be displayed? Dashboards are where this happens. Instead of querying numbers, you'll build visual interfaces that show trends, comparisons, and key metrics at a glance, and they update automatically. Super, super useful. Now for the fun part, let's create a create an e-commerce and analytics dashboard. We'll build a professional layout with KPIs at the top and detailed breakdowns below. So we can ask the ask feature here, what is a dashboard in Grafana? What makes it different from just running SQL? Again, super useful using these queries. We can use what are KPIs? Why do dashboards show them at the top? So KPIs, or key performance indicators, are quantifiable measures that show how effectively a company or organization is achieving its key business objectives. Cool, good to know. And we just touched on what a dashboard is. A dashboard is a collection of panels that visualize your data in one place. Think of the dashboard as a blank canvas and panels as individual charts or metrics you add to it. Each panel has its own query, visualization type. So there could be a stat panel, bar chart, or time series. I'm pretty sure we do each one of those. and formatting. Dashboards let you arrange these panels however you want, to put in KPIs at the top, detailed breakdowns below, and trends at the bottom. You can really do whatever though, that's just a common way of putting it together. Dashboards update automatically so teams can monitor performance without running SQL queries manually. In this step, you're going to create a dashboard with 6 panels, show key metrics with stat panels, orders by status with bar charts, and revenue trends with time series. And if you want to know what any of these are, just hover over the access the definition feature. What are we doing in this step? In this step, I'm creating a dashboard with Grafana MCP. Dashboards are different from SQL queries because they are set to query, which is like fetching information from data source automatically. Say opposed to running each query by hand. The panels will show orders by status, revenue trends, and other KPIs. Cool, so what are we doing in this step? In this step, I'm creating a dashboard with Grafana MCP. Dashboards are different from SQL queries because they are set to query, fetch information from data sources automatically, opposed to running each query by hand. The panels will show orders by status, revenue trends, and other key points of interest. Cool. And I totally recommend, if you're following along, to click this button. You can see your work, your documentation being generated on the side here. You can edit stuff here, or just check it out, how it looks. We'll go over this at the end, but yes, super cool. Super cool. Nice. So we're going to create your complete dashboard. Let's build the entire dashboard with a single well-structured prompt. This is really going to the strength of Cursor here. And we'll debug it if it doesn't quite work out. So open Cursor's chat. It's, Command L, Control L if you're on Windows. It's a bit bigger. So we're going to copy this prompt and send it off. So yeah, we'll just wait for this to go through, and I suppose while we wait, if I can get this to resize. I'll try and make this a bit bigger. I don't really want to though. There you go. And it's pretty common. You have to click add here or run them each time for a new MCP tool call. But yeah, let's see how it goes. It's a big prompt, so it'll take some time, and it might have do something wrong. We'll see. So what does this prompt actually do? Each query uses a as value. This tells tells Grafana which column contains the data source to visualize, from the data source. For time series charts, you'll use as time. For dates, as value. For metrics, panel formatting, the currency, USD, and number annotations tell the MCP how to format values. Currency, USD, adds 1, 2, 3, 4, 5, 6, while numbers show as 1, 2, 3, 4. Grafana supports dozens of formats, percentages, bytes, milliseconds, etc. Picoseconds, nanoseconds, whatever you want to set this up as, it can definitely support that. And there's auto refresh, which is what we've specified in the thing. It just is 30 seconds. You can actually go on Grafana and configure this to be instant. I think it's a couple seconds or a second. Or you can do a manual refresh as well. So Watch's cursor orchestrates the Grafana MCP, creating panels, writing SQL queries, configuring visualizations, all through natural language. Cursor will use the Grafana MCP to create an entire dashboard with all 6 panels. Okay, let's have a look. It's a big prompt, so we'll see how it gets on. It's very plausible. It gives us no data, and that's completely fine. We can go through and debug that. Okay, cool. It seems to have worked. So you can see total revenue there. This is like the key points of interest, key indicators. And see total orders, average order value, and total customers there. And we can see the bunch of stuff for order by status, revenue by region. I'll actually zoom out a little bit. Oh, that should be okay. Sort of fits the screen well. I just don't want my camera to get in the way, but it is there. Awesome. So yeah, I sort of skip this. You can click on, once you go to dashboards, you can click on the specific dashboard it created you just there. And it's very possible you see something like this with no data. There's great troubleshooting resources down here. If that doesn't work, go to the Ask feature here to get help. Or you can go talk to the community. We've got a great group of people there, really, really happy to help you out. Fixing errors or just chatting. But we'll go down this. So perfect, your dashboard is live. Oops, that's the Ask feature trying to help me out. Perfect, your dashboard is live and showing real data from PostgreSQL. What should I see? The top row, 4 stat panels showing total revenue, order count, average order value, and total customers. So we see here 2 bar charts breaking down orders by status and revenue by region. Order by status, revenue by region. Very good. Yeah, we can hover over, as I was just doing, charts to see the values, individual things. And this is the counter. You can do auto, 5 seconds, up to really long. You can click refresh. Obviously, the data isn't changing. This isn't a live data source. We'll get onto that in a minute. But you can refresh and update or go to different periods of time. So I'll just add a screenshot of this. What does your dashboard show? I created my dashboard by running a comprehensive prompt in Cursor to create 6 panels, both KPI and general charts. The top row shows metrics like, look at this, so we can say total revenue, total orders, average order value, and total customers. Like total revenue, total orders, total customers, and one more, average order value and average order value. The bottom row has bar charts showing order by status and revenue by region. Revenue by region. This helps me see So I guess the total revenue is around 5 million. That the total is around 5 million, and say the what is this? This is revenue by region has the highest revenue by region. Cool. So what does your dashboard show? I created the dashboard by running a comprehensive prompt and cursor to create 6 panels, both KPI and general charts. The top row shows metrics like total revenue, total orders, and total customers and average order value. The bottom row has bar charts showing order by status and revenue by region. This helps me see that the total revenue is around 5 million and LATAM has the highest revenue by region. Cool, and this is live updating, so if anything changes, you can just look back there. Cool, so now we're going to add the revenue trend over time. Now let's add a time series chart to see how revenue has changed month over month. And cursor will send this prompt here. What does this query do? This query calculates the total revenue for each month. It groups all orders by month, sums up their amounts, and returns time-based data that Grafana can plot as a line chart showing revenue trends over time. So you'll note that truncate is involved. Date truncate month, order date rounds each order date down to the first day of the month. This groups all orders from January into 2024, start of Feb, and all February orders into 2024 Feb, etc. It's how we aggregate daily data into monthly trends, so just grouping data by month in TLDR. The timestamp converts it to a format that Grafana can use to set up or read from. Apologies. So there's data truncate there for month and order date. Cool. So we can see it down there. I'll just scroll down so we can see. Refresh the browser to see your new panel. Click Zoom to Data button on the time series panel to properly fit the data. We can click that. Cool, we can see a nice plot there. Why zoom to data? By default, Grafana might show a time range that's too wide or too narrow for your actual data. Zoom to data automatically adjusts the x-axis to perfectly fit your data set's date range, making the trend easier to see. Oops. So you can see here this matches up what we've got here, so it's all good. What does this show you? Look at the trend line. Is revenue going up or staying flat? Do you see spike in certain months? These patterns tell a story about your business that raw numbers can't convey. In production, teams use time series to plot problems, spot problems early. Why did revenue drop in March? Or celebrate wins, holiday sales hit a record. This is data-driven decision making in action. So we can see here actually that potentially due to the way this has been rounded down, there is a huge drop in sales here. But this might be expected, perhaps if it's rounded down, it's early in the month. Upload a screenshot of your time series chart. Just zoom in a little bit. what does the revenue trend chart show? The time series chart shows the revenue of the e-commerce data set month by month over, this is, I think it's about a year, about 1 year. I can see trends like an average, or maybe we can say like we could say like an end of year drop off in sales. This type of visualization helps spot trends early. So before they happen, or like as they begin to happen, it's quite easy to look at time series plots that maybe you've pulled out of an e-commerce data set like we've just done to actually help understand and visualize what's going on. So what does the revenue trend chart show? The time series chart shows the revenue of an e-commerce data set month by month over about a year. I can see trends like an end of year drop off in sales. This type of visualization helps spot trends early. Perhaps you want to go and have a very concretely high or more stable sales across the year. You don't want that drop off. Then maybe this is a really good place to, start. Cool. So you've built a complete monitoring dashboard with stat panels for key points of interest, bar charts for breakdowns, and time series for trends. This is how data teams and companies like Airbnb and Netflix monitor their platforms in real time. Cool. Very good. So that's up until the secret mission, the project. But yeah, we'll be going to the secret mission, which is visualizing our dbt pipeline, data build tool pipeline. So ready for the secret mission, you'll visualize your dbt transformation pipeline from project 3. If you haven't done that, that's completely fine as well. We'll definitely catch you up. So you can see here what we're going to be doing, which is the PostgreSQL database. We've got a raw table, a dbt model, and then, or two dbt models, or two parts of a dbt model, I should say. Two different panels, same dbt model, which is customer country summary, and the raw table here. So want to see the full data engineering pipeline in action. Production teams don't just visualize the raw data, they build dashboards to show both data source, both source data and transform models side by side, demonstrating the complete flow from ingestion to analysis. You've already built monitoring dashboards with Grafana and PostgreSQL. This secret mission extends that by visualizing your dbt transformation pipeline, showing raw customer data alongside the transformed customer country summary model you created in Project 3. Look at that secret mission, indeed, Natasha. In the secret mission, you're going to verify that you have a dbt model table or create it missing, create a dashboard comparing raw versus transformed data, build panels querying both customers and app.customer country summary, so that's the dbt model and the raw data, compare query performance between raw and transformed approaches. Cool. What are you building in the secret mission? I'm building a dashboard that shows the dbt model and the raw data to compare, understand performance. This demonstrates the pipeline, a full data engineering team would utilize. I'll compare raw data versus a dbt model. where a dbt model is a data build tool model that is, say, automatically processing data in a predefined manner or way. Verify the dbt table. First, let's check if you have the customer country summary table from project 3. So we'll run this in the terminal and we can check that if we do, we can see it doesn't exist. So we're not going to go and click IC count, one row. So we can see we actually do, because we have the database set up to get here. We do have the table set up for that. So to figure that out, I ran the command and got the one row returned. And if you don't, that's completely fine. You can go and set that up with the error tab. So now let's create the summary table. This command simulates what a dbt does in production. It transforms raw data into an optimized pre-aggregated table. Instead of counting customers on every query, we'll calculate it once and store the results. So we're going to run this command in terminal. It's important if you're on Windows to not follow this, because it'll break PowerShell. It doesn't like sending multiple line commands, but just follow the Windows option here. Cool, so we got a response there, which is good. What did this command do? This create table as select command creates a new table by running a query and storing the results. It's essentially what a dbt does under the hood. It transforms source data into an aggregated summary table. This pre-calculated table makes future querying lightning fast. So if you get any sort of errors there, like column country does not exist, try using cursor add to chat feature to diagnose the issue, or check out the community as well. So we're going to verify the table was created. We can see the top 5 countries there, which is cool. Now we're going to jump back into creating the pipeline dashboard. So great, now that you have both the raw data and the transform model, let's visualize them side by side. So we're going to be creating a complete dashboard here for the dbt stuff and the raw data. So in cursor, let's send this prompt off. So let's create a dashboard with all 3 panels at once, demonstrating both raw queries and dbt model queries. So the first panel is going to have raw customer data. The second panel is going to have the top country statistics. So we're orchestrating a query there, and it's going to be a format table, panel type stat, configuration. For text display, that's unit is fine. We don't need to display. If it was like in kilograms, a unit would be useful there. We've got text mode, color mode, none, and a similar thing going on here. Another query to get total customer count, another statistic. We want a table in this case. Panel type is stat, and then the same sort of configuration, short. This is for like condensing numbers, so there's no halves or anything in total customer count, so that makes plenty of sense. Yeah, and then this first panel is raw customer data with the query to suit. Cool. Let's see what Cursor has done. So it says it created 3 panels. It's called the MCP, which is good. There should be a separate data dashboard database dashboard, and it seems to have worked. Doesn't seem to have any problems, so we can go have a look. So what I'll do is I'll head back to, you'll notice there's nothing different here, well at least there shouldn't be. So I'll just zoom out a little bit, and we can head back to dashboards. We can see a data pipeline monitor here. There's every chance that, well not every chance, but there is a chance that this we'll get this a no data issue again. But we can totally fix that if it comes up. Cool, okay, no problems. So we can see here the table we were speaking about, the custom account for each location. You can see Korea is there with the highest count, and you can see the top country there as well. And obviously, like I was saying, there's no need for a unit for this. And then we've got a custom account, which we're rounding this up to in the 1,000, so not a hyper-specific halved number. We can refresh here. We'll utilize that in a second, but it's good to know that it worked. And yeah, you can go to this link here to go onto it. So what's the difference between these three panels? Panel 1 queries raw data on the fly, slower for large data sets. Panels 2 and 3 query the pre-aggregated DBT model, instant results. This demonstrates the power of data transformations and really like where that comes into play in like live dashboards, why you don't want to do that. So we can actually now try watching our database or a dashboard update live. We update our database, so we can just send a prompt off to this. I've configured as Egypt, but there's really it's being pre-configured as Egypt, but we could set that as just for fun. We could do this to update more stuff. So we could do so the idea would be we can see this pop up to change to the second option, which is currently just behind Korea, and the number of customers per region or country, sorry. So we'll just give it some time, but this is instructing cursor to follow a query to go and update the database, and hopefully we'll be able to see Grafana update live, and that really demonstrates why we've actually done all this. So we can monitor live data if this was a real e-commerce store in this case. Cool, so we can see it going through and doing a bunch of MCP queries for the Postgres database we have set up inside of Docker, executing SQL, structured query language. It looks like it's just finished. We can jump here, and we just saw it update there, but anticlimactic. But you can see this top country jumped by, it was 16, now it's at 26, and it's still it's been moved to top country, and Korea has been shifted out of its spot. So we can see the live dashboard is updating, super useful, great outcome. And yeah, you can refresh here if it wasn't a 30-second long delay. Cool, so this demonstrates real-time monitoring. This is how production dashboards work. As data changes in your database, the visualizations update automatically. Teams can spot trends, anomalies, and issues the moment they happen. So you don't have to run a structured query language query by hand to understand something. and then just pick it up when you happen to run it. Running things automatically, super useful. But because of that, that automation. How did you add data and watch the dashboard update? I updated the dashboard by giving a natural language prompt to cursor to increase the number of customers in, what was it, Saint Kitts and Nevis. Probably move some of that there. Maybe you could say I used cursor to interact with Postgres via the MCP, as well as Grafana. The panels refreshed and showed a new top country, which was Saint Kitts and Nevis. Cool. So how did you add data and watch the dashboard update? I updated the dashboard by giving a natural language prompt to cursor to increase the number of customers in the Saint Kitts and Nevis. I used cursor to interact with PostgreSQL via the MCP as well as Grafana. The panels refreshed and showed me a new top country, Saint Kitts and Nevis. Very good. So compare their performance. Now we'll look what you've built. This demonstrates both the full data engineering pipeline. Panel 1, which is the raw data query, which is the table up here, showing off all the different countries we just updated. Queries, select country, count from app.customers, group by country, sorting it by country. Performance scans, all customer rows every time, slower for large data sets like this is. Use cases, flexible for ad hoc analysis, but not optimized. Panels 2 and 3, queries pre-aggregated customer country summary. Saint Kitts at the top. Thank you, Matt. Performance, instant results, data already aggregated, so much faster, even for huge databases. The use case of that is fast dashboard production monitoring, real-time analytics, like a Grafana dashboard. This PostgreSQL to dbt to Grafana pipeline, this is that pipeline in action. Why does this matter in production? In real-world data engineering, raw tables can have millions of rows. Running aggregates on the fly would be too slow for dashboards that update every 30 seconds. dbt creates materialized views that pre-calculate and do the heavy lifting for you. So your dashboard just shows both approaches in this case. So the raw query, which is a little slower, but a less layer of complexity, one less layer. And then transformed dbt models for speed. So we'll take a screenshot and upload that of our complete data pipeline monitoring dashboard. Just zoom out a little bit so we can see everything. What's the difference between raw and transformed queries? The difference between panel 1 and panel 2 is panel 1 directly queries the entire database, whereas panels 2 and 3 have the heavy lifting done for them, thus are much faster. Raw queries are direct fetches from a database, while DBT models are so you're building a SQL almost wrapper. You can do a Python wrapper with this as well to go and calculate some metric and then output it. So DBT models are wrappers for calculating specified, predetermined metrics you want to keep track of. In production, this matters because large data sets, really it's impossible to define what a large data set is, but let's just say a million plus rows start to slow down with a lot of, we'll say, raw queries. So what's the difference between raw and transformed queries? The difference between panel 1 and the other two panels is panel 1 directly queries the entire database, whereas panels 2 and 3 have the heavy lifting done for them, thus are much faster. The heavy lifting being the DBT model that's running the calculations there. While DBT models are wrappers for calculating predetermined metric, calculating a predetermined metric you want to keep track of. Cool. In production, this matters because large data sets, say a million plus rows, start to slow down when with a lot of raw queries. Cool. So that's the end. Before we go, we'll tidy up some stuff. I probably won't delete much because we'll use this, but we can go through and stop a few things. Cool. So nice work completing the project. Let's clean up the resources we created. So stuff to delete is stopping the Grafana container and decide what to do with PostgreSQL, keep, stop, or remove. So in the terminal, we'll run docker stop Grafana. Cool, you see the little Grafana tag there. That worked well. I'll stop PostgreSQL, I won't delete it. You can also run docker stop pg local, that's the name of our, to stop now. Of this pg local. Cool, and this extra thing here is the MCP server that's being ran, which will stop once we close cursor. Cool, and if you want to remove PostgreSQL completely, as well as the other stuff, you can do that as well. Just delete it. It's all good. If you stop it, it won't use any resources, or none of this costs any money. So yeah, cool. Awesome, that's a wrap. You did it. You've built Grafana dashboards that visualize your database's data, what you have learned, how to create and configure Grafana dashboards, connecting Grafana to PostgreSQL data sources, building visualizations with stat panels, bar charts, and time series, best practices for data visualization, using MCP Model Context Protocol to manage Grafana through natural language. That's a wrap. You're right now. The key tools I used were, I will send my documentation here. I will, after I fill out these 3 validations. Key tools I used were, say, MCP, Cursor, Grafana, Docker, and Postgres. PostgreSQL. The main concepts I learned were, say, database visualization. We'll say Grafana and dbt model versus dbt model versus raw query performance. What did you learn in this project? The key tools I used were MCP, Model Context Protocol, Cursor, Grafana, Docker, and PostgreSQL. The main concepts I learned were database visualization, Grafana, and dbt model versus raw query performance. How long did this take you? Look at the live stream, about an hour and a half. The most challenging part was, I'd say, understanding the dbt model performance benefits. It was most rewarding to visualize the time series data. So how long did this take you? This project took me 1.5 hours. The most challenging part was understanding the dbt model performance benefits. It was most rewarding to visualize the time series data. Maybe say visualize the data using a time series plot. Thanks for doing this project. Why did you do this project today? Did this project meet your goals? I did this project because I wanted to learn how to create a live dashboard for my data source. Data set. This project met my goals by teaching me how to use an industry standard data source visualization tool locally on my own data set. Cool, thanks for doing this project. Why did you do this project today? Did this project meet your goals? I did this project because I wanted to learn how to create a live dashboard for my data source, which was an e-commerce data set. This project met my goals by teaching me how to use an industry standard data source visualization tool. I'll put Grafana there. Grafana locally on my own data set. Cool. You can do the quiz as well. What is the primary function of Grafana in the context of data visualization? To transform SQL queries into interactive charts and dashboards, to manage document containers, to store and manage large data sets, to replace SQL for data querying. I would say to transform SQL queries into interactive charts and dashboards. What type of panel is best suited for displaying a single KPI, such as total revenue? I would say somewhat tricky. I think it's arguable that a stat panel is probably the correct answer here. Although if we think about well, I've just closed Grafana, so that's why that's not working. But a stat panel is like something that shows a numeric value, and a bar chart would be something which shows generally you look at that for like a trend or a time series chart for a trend. So stat panel is my answer. What does the date truncate month function do in SQL query for Grafana, for a Grafana time series chart? It calculates the difference between the order date and the current date. It calculates, that's A, it calculates the total number of days in the month. It formats the order date as a timestamp. It rounds each order date to the first day of its month, grouping all orders from that month together. D. Why is host.docker.internal used instead of localhost when configuring a PostgreSQL data source? In Grafana, localhost is for web applications. Grafana and PostgreSQL are running in separate Docker containers, and host Docker internal allows Grafana to connect to the host machine. I think it's that one. Host Docker internal is a more secure connection. Localhost is faster for local connections. B. And last question: what is the purpose of a data source in Grafana? To store API tokens, to manage permissions within Grafana, to specify where Grafana fetches data from, such as a PostgreSQL database, to define a visual theme for the dashboard. I think it is C here. Cool. Okay, see if there's something which is stopping us. I'll just full screen this. Cool, so we can see our documentation here. Super duper cool. I'll put a link in the chat now. I think that'll turn into a link you can access. Yes, it does. How good. Cool, so we can see our first dashboard we made there, talking about today's project. Cool, verifying MCP connections, creating a PostgreSQL data source, verifying it's all good, connected, building the first dashboard, talking about dashboard insights, talking about the revenue trends we can see here, visualizing the dbt pipeline, and updating the dashboard, and understanding the performance comparison aspect of what's going on here. Cool, I'll just pull this back up. So we can click mission completed here, and we can download a documentation. This just takes us to this, or we can share it on LinkedIn. I'll just shift to my personal account here. This will take a second. Cool. Very nice. Yeah, no, super cool documentation. You can also play around with the theme here. It looks great. All right, I think I'm done. I'll wait for some questions if there's any at the end. But if not, then I will head off. But it's been super cool. This is one of my favorite projects for sure. Like, I think the outcome and like the sort of the flow here, looking at the stuff we've done related to other projects in the same series and in the AI Workspace series, is just so cool. Like, it's a really full circle moment showing this off. And Grafana is such a cool tool as well. And yeah, you can also go and replace and edit text here. So if you need to in the editor here. But I think I will head off now. But it's been, I hope Sean and Raj have followed along and are doing real well. Yeah, stoked to have some more projects coming out in the near future.